This video serves as a quick review of chemical reactions, what they are, what evidence to look for when a chemical reaction happens, and then we'll also spend a little bit of time talking about the conservation of mass in a chemical reaction. So what are chemical reactions? Chemical reactions are processes in which a chemical change occurs, and that chemical change causes one or more substances to turn into one or more new substances, and those new substances have different chemical or physical properties. In general, it goes like this. The substances that are starting to react, or the original substances, they're called reactants, and after the chemical change occurs, they turn into what we call products. So we start with reactants. Right here, there's the reaction, often abbreviated as RXN, and then you get products. So what actually happens in a chemical reaction? We did a whole lab on this with Alka-Seltzer, but if you think about it, what you actually end up happening is you have the original substances, the bonds between the atoms or molecules in that substances, they break apart, and the atoms rearrange themselves to form new substances. So if you remember from the lab, we had hydrochloric acid and we reacted it with sodium bicarbonate, often, which is the Alka-Seltzer, but also the formula for baking soda. And when they reacted, this happened. You made carbon dioxide, which is a gas, you made water, and you made salt, three completely harmless substances. But if you look carefully, what you'll see is that the atoms on each side haven't changed, right? Over here, we have, and I'll do this in highlighter so you can see it, but over here we have 1, 2 hydrogen atoms, and over here we have 1, 2 hydrogen atoms. We have 1, 2, 3 oxygens and 1, 2, 3 oxygens. 1 carbon, 1 sodium, and 1 chlorine, 1 chlorine. So we didn't add any atoms, we didn't subtract any atoms. All we did was rearrange the atoms, breaking their bonds, and then forming new bonds. So in the lab, we can't actually see this rearrangement of molecules, so instead we have to look for other things that show us that chemical reactions occurred. And these are things like our change in color, the formation of gas bubbles, but you gotta be careful with that one because sometimes it could be evidence just of boiling. You get an odor, you could see a change in temperature, that's a good one. You might see light. I know some of you guys have seen the burning of magnesium to form magnesium oxide. It makes a very, very bright light. And the last one is the formation of something called a precipitate. If you remember, a precipitate is a solid that falls out of the solution. And we see this a lot, and you guys have already learned about these in double replacement reactions. So this is a solid that forms out of solution because it's not soluble anymore. And so you see this colored precipitate. And if you want a little bit more, you can read the notes on chemical reaction basics. So as I said before, we don't actually add any atoms, we don't take away any atoms. This is known as the law of conservation of mass. And what it really says is in a chemical reaction, no matter is created or destroyed. Therefore, the mass of the reactants equals the mass of the products. And it's often written as mass of reactants, which is R, is equal to mass of products, MP. And there's some practice problems for you guys to work on this. So I want to show you one practice problem, and then we'll go from there. So this is what a conservation problem would look like, and it says in an experiment 10 grams of red mercury oxide powder, mercury 2 oxide powder, is heated until it is converted into liquid mercury and oxygen gas, and there's a balanced equation for you. And then it says if at the end of the experiment 9.26 grams of liquid mercury remains, calculate the amount of oxygen gas produced. So let's remember basically that the mass of the reactants is equal to the mass of the products. Therefore, the mass of mercury oxide is going to be equal to the mass of mercury plus the mass of oxygen gas. And the coefficients, which are these big numbers here, they don't mean anything here for this. So we know that if we're going to start with 10.00 grams of mercury oxide, and at the end we have 9.26 grams of mercury, whatever's left right here is going to be the mass of oxygen. So very simply, this is 10.00 minus 9.26. When I solve it out, that's a 4, that becomes a 7, that becomes a 0. The last thing we do is I'm going to check for sig fig. These both go to the hundredths place, so this should go to the hundredths place, and therefore my answer is 0.74 grams of oxygen gas. And these are really simple problems as long as you remember the sig fig for subtraction. So just a few final reminders. Remember that in a chemical reaction, We have subscripts and coefficients. So, for example, we have this chemical reaction, which is 4 aluminum, gives us, added to 3 oxygen gas, gives us 2 aluminum oxides. These big numbers tell us how many of each atom or molecule are there. These are the coefficients. These little numbers that are determined basically by the rules for chemical bonding, those are subscripts. You also will need to make sure that you are able to count atoms and ions in a formula. So for example, let's look at the compound calcium phosphate, which is Ca3PO4, 2. PO4 taken twice is actually the proper way to say it. In this, we have 3 calcium 2+ ions. We also have 3 calcium atoms. We have 2 PO4 3- ions, but we have 2 phosphorus atoms and we have 8 oxygen atoms. And if you don't remember how to count that, just remember it's a multiplication problem. So 2 times 4 is 8. So that's just a few fun reminders on subscripts, coefficients, and counting atoms, but most of this is relatively easy and should be reviewed.